Alrighty then, let's see if we have anyone following along. I think we have two in the chat, but I'll just get started. So this is my stream where I will be covering some of the basics of mass balances, and basically we're gonna start out with the very basics. I put up some assignments you could try yourselves. I have swapped 1 and 2, but we'll go through both of them today. And in general, what we'll be looking at today, first of all, is this lovely balance of mixing reactions. But before we jump into that, let's see if I can add myself. There we go. We need to go over some of the fundamentals of mass balances. Now, there's a couple of rules that we need to have in place before we really get going. The first rule is, if I have a stream that is made up of different components, those component percentages must add up to 100%. So that means if I have 25% ethanol and the balanced water, well, then the water must be, what's that? 75%. Jesus, stressing when streaming. So that's one of the first rules we need to have in place, is that we say all of the compositions in every stream must add up to 100%. The next one is the basics of mass balances, in equals out. So we're not dealing with any chemical reactions today. That means if I put 20 kilograms in, 20 kilograms comes out, no matter where I'm looking in my system. So that has to be obeyed at all times. Was there anything else to start off with? Well, there's one thing that I know some of you have been struggling a bit with. Let's see if I can. I'm gonna try and draw here with a large marker. But one of the things I've seen many of my lovely students make a mistake about is, let's say that I have a box and I'm sending in something. Let's say I'm sending in 0.5 of ethanol and 0.5 of water. And then I have two streams exiting here, top and bottom. And maybe I then say, well, up in the top stream here, I have 96% ethanol. And that leaves me with 4% of water. And let's just say, let's make it easy for me, I'm sending in 100 kilograms into this system. Now, some of you seem to interpret this as, well, 50 kilograms of ethanol comes in to the system here, which is correct. So I have 50 kilograms of ethanol entering into my system. But then you seem to think that this means that 96% of that ethanol ends up in the top stream. That is not what this information is telling you. This information is purely telling you that if you look at the top stream up here, if I were to cut this pipe in half and look inside of it, 96% of the mass that I see up in this pipe would be ethanol. Now, I could easily have a very small relative amount of ethanol. I would just have an even smaller amount of water. So you cannot say from this, well, 96% ends up here. No. That would be if I told you that I want, let's say, 96% of my ethanol recovered in my top stream. Then we can say 96% of the incoming ethanol must end up in the top stream. But this is just telling me the composition of the top stream. So we can't do that. Now, I'm going to start out with the one we were just looking at. It might be a bit difficult to see on stream. Let's see if we can scale it up. It might look horrible. But basically, I have two streams that I wish to mix together. Both of them contain methanol water mixtures. In this case, it's described as two flasks. The first mixture is 40% weight percent methanol, and the second is 70 weight percent methanol. And then I'm told the mass of the two different ones that I want to send into my, send into my system. So the first thing I want to do is, of course, I want to take this information and I want to try and draw a system. So we're going to look at how I would draw that system. I would like a small box where I can mix my streams. Then I have a great big stream entering here and entering here. And then I have my product exiting somewhere. And now, of course, I cannot remember. I'll just move it to the other screen. So now I can see what I'm doing. Perfect. So I know that one of my streams contains 40 weight percent methanol. So 0.4 of methanol. That must leave me with 60% of water. And I decide to do the same for the top stream here, where I know it's 70% methanol. So 0.7 of methanol and 30% of water. And I'm also told the masses. So I know that for this left stream, I want 200 grams. And for the top stream, I want 150 grams. So this is basically the system that I'm working with, and I have to figure out, okay, what comes out of this mixture. Now, again, a lot of you seem to not really be comfortable with using percentages and calculating the, the compositions. So for instance, when I'm looking at this, well, I know that I'm mixing a 40% methanol with a 70% methanol. I don't know what the exit concentration will be over here, but I can already say it's gonna be somewhere between 40 and 70% methanol. How do I know that? Well, consider if instead of using 200 grams and 150 grams, we just used an infinite amount of the first stream, for instance. So that means the second stream is basically insignificant. We don't have to deal with it. Then my concentration would be 40%. Similarly, if I had infinite of this stream, well, then my exiting stream would have the composition of 70% methanol. It's like when I mix, if I take two beers and I pour them into a glass, one beer is 4%, the other is 5%. I'm not going to end up somehow with a 10% beer or a 2% beer in my glass. That's not possible to do. Okay, so now that that's settled, I'm going to solve this by hand first, and then we'll look at setting it up in Excel. So in this case, it is fairly simple when I'm looking at it. So first of all, let's give the streams some names. Stream 1, Stream 2, Stream 3. And the first thing I'm going to do is I'm going to say, well, let's do a mass balance for this lovely system. I'm going to look at that box and say, okay, what comes into that box? Well, that would be Stream 1 and Stream 2. And what comes out? Well, that would be Stream 3. Now, solving by hand, I can do shortcuts. So I can already say, well, I know that I have 200 grams here. I know that I have 150 grams for Stream 2. So I can already say that my Stream 3 must be 350 grams in total. Okay? Just move stuff around on my desk. Don't fall. Yes! Now, the next thing I'm going to do is I'm going to just only focus on the methanol. So how much methanol is entering my stream? I might need a calculator for this, so let me just fire up a calculator. By the way, if there are questions, if it's going too fast, you can just write in the stream chat. I'll try and keep an eye on it. But basically, if I look at my incoming here, I know that I have 200 grams. I know that 40% of it is methanol. So that would be 0.4 times 200, which gives me 80 kilograms. So I'm going to write that here. Or was it grams? I think it was grams. 80 grams of methanol is entering here. And in my other stream, I have 70% of 150 grams. So that means up here, I'm adding in 105 grams. And all I've really done here is I've taken this equation here, my total mass balance, and I've multiplied first this one with the percentage of methanol, then this one with percentage of methanol, and finally over here, I don't know the concentration of methanol, but we're going to pretend I multiplied it onto this, okay? So I have 80, and I have, where was the other? 105. That should mean that the amount of methanol exiting my stream over here should be 185 grams. And if I then want to know the concentration, well, all I need to do is take the mass of methanol divided by the total mass, and I can't remember what that is. That should give me right around 52%, so 0.529 if we round up. So I now know that 52.9% of my exiting stream is methanol. I could similarly then calculate it for the water, or I could just take 1 minus this percentage. Again, the sum of all of my compositions have to add up to 1. So at this point, I've basically solved the first problem that we were going to be looking at, because I know the mass, 350 grams, is going to exit. The composition, well, it's going to be 52.9% of methanol. So now we're going to have a look at how I could set this up if I wanted to solve it in Excel. Now, I have an Excel open. I have tried to basically turn my lovely computer into grandma mode, so everything is nice and big, and hopefully we can all see what's going on. But now I can't even count. I'm gonna start out with my 3 streams, 1, 2, and 3. I'm gonna enter my components. So let's say I have my ethanol, I have my water, and then I have my total mass, my ethanol mass. Oh, sorry, it's actually methanol. Oh, I can't deal with that. There we go. And my water. Now, the percentages that I've been given is that I know in stream 1, I have 40% of methanol. In stream 2, I have 70. In stream 3, I don't know how much there'll be. So I'm going to mark stream 3 and say unknown. For the water, for all of the streams, I'm just going to say, well, I have 2 components. The percentage is going to be 1 minus the other. And I don't care that the bottom one doesn't match right now. That's totally fine. But I also know I am adding 200 grams of stream 1, 150 grams of stream 2. How much of stream 3? I'm going to play dumb and say I don't know. And then I can calculate how much methanol and water I have. I do it by taking the total I have in the pipe, in the stream, and multiplying it by the percentage. So in this case, 40% methanol. You'll see that I put a lovely $sign in front of the letter D. By doing that, I am able to copy paste my equations to the right and down. It's now being calculated for all of these, even for the one that doesn't make sense right now. And finally, I can, so technically, let me just jump back to my drawing here. Technically, I could set up a total mass balance and a balance for each unit operation. When you only have one unit operation, they are going to be perfectly identical, so there's no point. So we're going to draw it for unit 1, and I can basically do it for the 3 components that I have, or 2 components and the total. So we look at our drawing. Let's jump back. I know from my equation here, stream 1 and stream 2 enters, stream 3 exits. So I'm going to say stream 1 plus stream 2. And then I'm going to subtract the streams that exit. In this case, it's just stream 3. And that's my mass balance for the total mass in this system. And I can just copy it to the right. And we can see as we move to the right, the balance for methanol use the same streams, but the masses for methanol. So now I need to make sure that I can actually solve this. I have 2 lovely yellow unknowns. I have 3 equations, but only 2 of them are independent. We have to keep an eye on that, okay? So I'm gonna set up solver, and I'm basically gonna say I would like my first, so my what's it called, total mass balance. I would like that to have a value of 0. I would like to add a constraint that my other independent equation has to be equal to 0. When we have that, I have to tell Excel where can it make changes, what can it do to try and solve this. So we're gonna tell it those two yellows, please change values in those in order to solve them. We offer up a silent prayer to the Excel gods, and there we go. Solver found a solution, all constraints are optimal, blah, blah, blah. And because we did it by hand, we can just check, what did I say? 52.9 if we round up, 52.85 rounded up, yeah. So that's basically how you would solve a very simple mass balance in Excel. And we can just check and say, yeah, all of these are fairly close to zero. If we think these don't look too nice, the last two, we can try and see if Excel just needs a little shove to get a bit better results. That turned out a bit better, but it doesn't change our conclusion. So usually that's not an issue. So that's how we would solve a very simple mass balance in Excel. And let's jump on to the next one. So this one, same principle really. We just have three components. In this case, we have our sodium nitrate, we have our insulin, and then we have our solvent. In this case, the solvent is ethanol. So let's try like we did before. Where did I put my pen? Oh dear, it's disappearing. So, and again, I need to be able to see what I'm trying to draw. I'm mixing two streams. So again, I want a little box. I want one stream entering and another. And then I want a stream exiting. And we just put in our information. So for stream 1, we know that, okay, top stream, yeah, whatever. Stream 1 contains 23% of sodium nitrate and 15% insulin, and the balance of, not water, sorry, ethanol. For stream 2, I know that it contains 13% sodium nitrate, no insulin, and the balance of, again, not water, why do I want to keep saying water, of ethanol. Oh, and while I remember, go. And what else do we know? Well, we know that 130 kilograms of this one has to enter, and we know that 100 kilograms of this one has to enter, and all of that ends up in stream 3, which will have some percentage of, what shall we call that, XNA, some percent of sodium nitrate, some percentage of insulin, and the balance water. Okay, similar to before, we can create a mass balance around this entire system and say, well, stream 1 plus stream 2, I can't even write, stream 1 plus stream 2 has to be equal to stream 3. And again, doing it by hand, quick math, 130 and 100, I must have 230 kilograms exiting over here. Then I could do it for sodium nitrate, I could do it for insulin, it doesn't really matter, but we'll just go through both of them. Insulin is very easy, it only enters in one stream over here. It's 15% of 130. 15, oh, where am I typing now? Hang on. Calculator. 15% of 130. That means that the mass of insulin, not the percentage, the mass over here of insulin will be 19.5. And if I want to know the percentage, I take 19.5 and I divide it by the total mass. So I take 19.5 divided by 230. If I do that, I get approximately 0.085 if we round off. So that was my insulin. I can do the same for sodium nitrate. 23% from this stream, so 23 or 0.23 times 130. So I have 29.9 kilograms entering in that stream. In the other stream, I have, that must be 13 kilograms. So in total, I'll have, oh dear Lord, 42, where can I write that? We are just gonna remove this and write it down here. So total, we're gonna have 42.9 kilograms. And again, 42.9 kilograms divided by 230 gives us 18%. Okay? So that's how you would solve that mass balance by hand. At this point, we know all of the masses and we know all of the compositions and everything is fine. I haven't calculated the water for all of them, but that's basically just taking, let's do it for the final stream, 1 minus the 0.085 minus the 0.18. So that means for the water over here, I would have a percentage of water of, what did I say, 0.735. Yes, the stream will be saved so you can watch it later. It might take a little while because I think I'll split it up so you have assignment 1, assignment 2. But yes, you can rewatch this at a later date. So that's basically how you would solve it by hand. Now onto our favorite tool in the engineering box. We need to solve it in Excel as well. I'm gonna fire up a new sheet. Oh, and also for all of my students' information, I don't know if we have strangers watching. If so, welcome. But I will be putting up all of the Excel sheets that I create during my streams. I'll put them up on It's Learning so you can get them from there as well. But on to solving this lovely thing. Again, I have 3 streams. There we go. In this case, I have 3 components. So I have sodium nitrate, I have insulin, I have ethanol, and I then have my total. And just because I'm lazy, I'm gonna cheat and say like that. So I have my total, I have my components, and then we just have to type in the information we're given. So in the top stream, we have 23% of this one, 15% of that one. In the bottom stream, we have no insulin. We have 13% sodium nitrate. And for the, I have to do it right, for the rest here, we just subtract the sum of all of the others. Why do I do the sum? Because when we have 20 components, it's much easier than having to go that cell minus that, minus that, minus that, and click all the way through. So here I just sum up all of the others. There we go. And fill it down. And actually we can fill it down to there. So these two, no, oh dear. These two, no idea what my composition is gonna be. The total mass, well, I know I have 130 kilograms of that, 100 kilograms of that. Bugger idea what will be there. And finally here, again, I can take my total with $sign in front of the letter, multiplied it by the composition of sodium nitrate, and I just want to fill it right and down. And all of these are now determined by what is in the different cells over here. Just so we can all see what's going on, I'm gonna do what I'm not allowed to do and write my equations someplace else. So down here, I have unit 1, and we can actually, just for the fun of it, let's write the system balance as well. So for my unit 1, let's jump back to the drawing. I have stream 1 and stream 2 are entering, stream 3 is exiting. So that's the equation I want to type in. In case some of you are not entirely sure what I'm doing in Excel, let's just try, where do we have it? Here. So basically I have the equation that says the total mass of stream 1 plus the total mass of stream 2 has to be equal to the total mass of stream 3. Excel doesn't handle this type of equation that easily, so I'm going to use a small trick and say, well, if I take the right-hand side and subtract it from the left-hand side, so if I say stream 1 plus stream 2 minus stream 3, if these values are all correct, that should give me a 0. So you'll see I do that all the time with equations in Excel, and that's just to streamline my workflow when I'm using Excel, basically saying all of my equations, whenever I have any equations, they have to be 0. If they're 0, that means that my system is solved and everything is as I want it to be. So let's look at our first unit. We wanted stream 1 plus stream 2 minus stream 3. And we can see right now it gives me 230. Why? Because I have no value here, so we already know this is not balanced. And I'm just gonna fill that to the right so that it uses first sodium nitrate, insulin, ethanol, and then we're happy. Now, just for the fun of it, we're gonna do the system as well. We go back to there we have the drawing. So for unit 1, stream 1 plus 2 minus 3. For the entire system, there's only one unit, so it's stream 1 plus 2 minus 3. So not very interesting, because it's gonna be exactly the same equation and I can't use the equations anyways, because if you recall, if we set it up like this, if I want to remove all of my dependent equations, a quick and dirty way, remove the bottom row, remove the outermost column. There are more details to it later on, but for now, remove the bottom, remove the one furthest to the right. That leaves me with 3 equations. I have 3 unknowns. That means 0 degrees of freedom. If I set it up correctly, I should be able to solve this. So let's jump over to our solver. And again, I'm gonna pick one of them. So first equation, value of 0. What constraints do I have? Well, I would like the other 2 independent equations to be equal to 0. And finally, what can Excel change? Those 3 lovely things. 3, everything looks fine. With a bit of luck, Excel finds a solution, and we can see everything seems to be balanced. Actually, let me just check. I did make these ahead of schedule. So where do I have the correct one? Oh dear, I must have mixed something up. Why is it? Hang on. Here we go. 230. Yes, everything checks out. And if we want to, we can look what we got here. We said 18%, 8.5%, 73%. What did we end up with? Where is it? 18%, 8.5%, 73%. Yeah, close enough. So that's basically how you would approach solving a typical mass balance. Of course, once the system starts to grow in size, it becomes a bit more complicated, but basically follow the same steps all the way through. And then, I mean, you saw how quick this went. I know I've been doing it a while, so fair enough. But yeah, that I believe was all I had planned for today. So for tomorrow's stream, I will go through the distillation, where we have a lot of weird information to put into equations. I will go through this corn steep liquor mixing, where we have 3 streams being mixed together. And I will go through this one, where we have a lot of information and we have to figure out, you can also see at this point, we are scaling up to having more unit operations. So that's my plan for tomorrow. If you want to watch along, you're welcome to do so. For my students, if there's anything in particular where you're like, could you go over this assignment or that assignment? Remember, question hours tomorrow from 12 to 2 if you're interested, or let me know on It's Learning or via mail. And I can try and see if I can include it in the streams so I can cover other things as well. So if you want me to, for instance, go through the homework assignments A, B, C, and D, well, let's not do all of them in one night. We all have to survive. But let me know if you want those covered as well. And that's basically it for me. Thank you for joining me, and hopefully you'll have luck with the mass balances. The streams will be up. Who says this? No, of course it doesn't, because we're scientists. We don't use degrees Celsius or Fahrenheit. Only kids do that. But you're out of school, kid, so that's fine. But yeah, that's it for me today. Let me know if there's anything else you need help with. See ya!